Okay, we'll get started in just a minute or two. Should be in chapter 8. We'll continue on lecturing from where we left off. Again, we'll get started in just a couple of minutes here, a couple of seconds. All right. So last time we were talking about acids and bases, and we talked about a couple different things. We talked about definition of an acid, the Bronsted-Lowry definition, which is a proton donor. So again, that is something that will give away an H plus. While a base, a Bronsted base, is a proton acceptor. And remember that that brings up basically partners that happen when you take an acid plus a base. On the other side of the arrow, you will get is conjugate acid and conjugate base. So conjugate base plus your conjugate acid. And again, you may have to adjust the volume on your side just to make sure you can hear me. Again, I can't go too loud, otherwise I think I get feedback. But if you're having some trouble, maybe try to adjust it and see if that gets better for you on your side. And remember that when we have an acid, is partner on the other side is its conjugate base, while if we have a base, is partner on the other side there is his conjugate acid. So the only difference between those two things, as we talked about last time, is just one H plus. So one H plus is the only difference that there can be. And remember that your acid and bases are essentially on the reactant side, while your conjugate acid and bases there are on the product side. Any questions on that stuff there that we talked about? And towards the end there, we got to talking about calculating the H plus concentration and the OH minus concentration. Remember that there's a relationship which we still have scribbled up here in the middle. This relationship, which is known as Kw, and Kw equals the concentration of H plus times the concentration of OH minus, and that equals a constant which is 1 times 10 to the minus 14. And you could use that with these two sort of ways down here at the bottom. And it's basically the same calculation no matter which way you do it. You can either take 1 times 10 to the minus 14 and divide it by the H plus concentration if that's given to you, or you can take 1 times 10 to the minus 14 and divide it by the OH minus concentration if that's given to you. So really, whichever one is given to you, you pretty much just take 1 times 10 to the minus 14 and calculate it. As you can see with the other stuff that's scribbled up here on the screen, these are definitely from all these calculations for the rest of this chapter here. You do want to make sure that you are using your exponent button, especially in just a bit here. We'll start using log as well. And if you're not using that EE button, that EXP button, you're going to find yourself pretty far off a lot of times in terms of the right answer. So you do want to make sure that you always enter these things in scientific notation using the button, like we talked about way back when, at the very beginning of the semester. Also, a reminder that when you do get the answers, your answers may not be in scientific notation. So you can convert to scientific notation if you want to. If you don't want to, then you'll have a lot of zeros in a lot of these answers. So once we calculate the H plus concentration, which also a reminder when we're talking with acid and bases, when we see the concentration of H plus, which is what the little brackets mean, and that is the same as H3O plus. So again, H plus and H3O plus. H3O plus is what is known as the hydronium ion, and it is essentially the exact same thing as H plus. So again, it's used interchangeably, both in formulas and also in sort of equations as well. But when we see that little bracket, it means concentration, and again, what it means usually is molarity, which again is our moles per liter. So that's essentially what that means. So we can compare those two values that we get. We can compare the H plus concentration and the OH minus concentration. And whichever one is larger will tell you whether or not the solution will be acidic, basic, or neutral. So if your H plus concentration is larger, your H plus is really kind of the acid part of the solution. So if that number is larger than the OH minus, which is the base part of the solution, then it will be an acidic solution. Vice versa, if the OH minus concentration is larger than the H plus concentration, again, the OH minus concentration is the base part of the solution. So if that's larger than the H plus, then the solution will be basic. And the last option is a neutral solution. And that would be right here. In order to have a neutral solution, the H plus concentration will have to equal the OH minus concentration. And that means that at that point, they both will equal 1 times 10 to the minus 7. So that's basically what neutral means. The H plus concentration, which is the acid part of the solution, will equal the OH minus concentration, which is the basic part of the solution. Any questions on that or anything like that? And again, if you do have questions, feel free to type them in as we go along. I will definitely get there and get to your questions. All right, so now that we've talked about that and we did last time, here are a few problems. So for each of these concentrations, why don't you calculate either the H plus concentration or the OH minus, depending on which one they give you. And we want to know, is it acidic, basic, or neutral? So why don't you take a few minutes here and work out each of these. So you should end up with 4 answers, one for each of the ones that are listed there. And is it acidic, basic, or neutral? So again, for our first one here, you would want to figure out what is the OH minus concentration. Also for our second one. And the last two, we're looking for the H plus concentration. So once you get your calculator, once you give it a try here, take a few minutes or so to do it. Make sure, again, you know how to properly punch these things into your calculator. And we'll talk about it in a few minutes. So give it a go. So let's take a look here at these. So looking at the first one, we are given the H plus concentration, and pretty much it's the same calculation no matter which one you take. So no matter which one that you grab, it is going to be basically the same calculation. We want to take 1 times 10 to the minus 14, and we want to basically divide it by our other concentration. So if we do that, we're going to take 1 times 10 to the minus 14, which is a constant. And we're going to divide it in this case by 3.4 times 10 to the minus 4. So again, just a reminder that when we punch something like this in, what you want to do is you want to hit 1. And again, you want to use your exponent button. And again, on your calculator, it may put a 1 and an E, or it may put a 1 and pop up a couple of zeros. But again, both of those things represent the times 10 part of the number, which again means you do not need to hit the multiplication button, the inverse log, or anything like that. You would just simply put in the next part of it, which is negative 14 in this case. Again, you want to use your negative button, which maybe looks like that, or it may look like this, not your subtract button, and then 14. Then obviously you would hit your divide button and put the other number in the exact same way, 3.4, your exponent button, and again, your negative button, and 4 in this case. And then obviously hit equals. And if you do that, what we will get is something like, I didn't have a box in the way, I can see it. 2.9 times 10 to the minus 11. And since this is a concentration, we would put molarity, and the units would be molarity because the original unit up here was molarity as well. So we would get that. First off, any questions on the calculation there? Again, a reminder that your calculator may not spit it out to you in scientific notation. It may and may not. Here we went to 2 significant figures because the original number was 2 significant figures as well. So now what we want to do is we want to determine whether or not this solution is acidic, basic, or neutral. And to do that, we want to take the OH minus concentration we just had, and we want to compare it to the H plus concentration that was given to us of 3.4 times 10 to the minus 4 molar. And we want to see which one is larger. So when we look at this, hopefully you could see that actually the H plus concentration there is a bigger number than our OH minus concentration. And because this is bigger, this would tell us, since this is the acid part really, and this is the base part, that this solution should be acidic. Any questions on that part of it? So that sometimes confuses people, the kind of comparison part. So what you're trying to compare is the H plus concentration, which is your acid concentration, to the OH minus concentration, which is your base concentration, and whichever one is larger. Again, just sometimes people get confused with this part of it. They're like, wait, 4 is a smaller number than 11. But you have to remember what that number means. That negative means, for example, that for our H plus, it would be 0.00034 molar, right? Going 1, 2, 3, and 4 places. I should have started here actually. 1, 2, 3, and 4 places, not starting there. And the other one means that essentially we have something like 10 zeros. I wish I was counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not bad. And a 2 and a 9 here. So you can see, even though this number has the larger exponent, it's actually a smaller number because there's a lot more zeros. So when you have a negative exponent, the smaller number is the larger number when you have a negative exponent. Again, because you're going to put all those zeros basically, to the other side. Any questions on that calculation there? Okay, so we're going to continue on here and get down here. Take a look at the next one. We also have the H plus concentration given to us. We're going to set it up the exact same way. We're going to take 1 times 10 to the minus 14. We're going to divide it by 2.6 times 10 to the minus 8. Again, using our exponent button on both of those numbers. And here, if you do that, that gives you an OH minus concentration of 3.9 times 10 to the minus 7. Any questions on that part of the calculation? And again, on your calculator, like mine, if you punch that in, I get something like 0.000000385. Again, a lot of times it's easier to put these into scientific notation because there are a lot of them are very small numbers and so forth. So it's a lot easier. So at this point, we want to compare the two. So really, honestly, to compare, you really just need to look at this part most of the time. So the acid part, which is up here, is 10 to the minus 8. The base part, which is our OH minus, is 10 to the minus 7. This one is actually a larger number, which means this one should be basic in this case. Any questions on that one? I think I might have mentioned it last time as well. When you're asked those questions, is it acidic, basic, or neutral? Again, there's only one answer for that. The same solution can't be acidic, basic, and neutral at once. So it's got to be one of those. So on all questions in this chapter, and it's very common, people will do it. They'll give all three answers like, yeah, it's acidic and it's basic. So again, for one solution, it will either be acidic, it will either be basic, or it will be neutral. All right, so continuing on, if there's no questions on that, looking at our next one here. Here we have actually the OH minus concentration given to us. So we want to calculate the H plus concentration. And like I said, it really doesn't matter which one's given to you. It's pretty much the exact same calculation. And again, you always have that number 1 times 10 to the minus 14. And that is what KW equals. And we would take the 1 times 10 to the minus 14. We would divide it by 6.2 times 10 to the minus 9. Again, using our exponent buttons and everything, we end up with a H plus concentration, in this case, of 1.6 times 10 to the minus 6. Again, to figure out acidic, basic, or neutral, again, the H plus is really the acid part. The OH minus up here is the base part of the solution. So we see that the base part is 10 to the minus 9, which means that the acidic part here is 10 to the minus 6. So again, this is going to be larger, which means this solution will be acidic in this case. Again, the minus 9 means for the top one, we're going 9 places to the left with zeros put in there. The bottom one, we're only going 6 places to the left with zeros. And again, gives us a larger number. Any questions on those three so far? Hopefully you're getting the hang of your calculator. And our last one here, also we're given the OH minus concentration. So that would allow us to calculate the H plus concentration. And again, it's 1 times 10 to the minus 14 divided by 8.1 times 10 to the minus 3. And when we get the H plus concentration, looks like 1.2 times 10 to the minus 12. Again, two significant figures because of the original number. And again, also when you're calculating concentration, you should put the unit, and it's usually molarity as well. So our acid part in this case although I scribbled on it, is 10 to the minus 12, while our base part up here is 10 to the minus 3. So this one up here is actually going to be larger in this case. And since the base part is larger, that would make this solution basic. Any questions on how to calculate H plus, OH minus using KW? And again, as I mentioned earlier and before, this is the same as H3O plus. Exact same thing. Any questions on any of those? How we got the numbers? How come one's acidic and basic? Okay, again, if you do have questions, feel free to ask. There's another example here. Forget about the which one is greater. Just calculate the OH minus concentration. So why don't you just calculate the OH minus concentration and see what you come up with. And then we'll talk about it here in a second. Okay, so again here, whenever you're given either the H plus or OH minus concentration, a lot of times KW could help you, which again is H plus times OH minus equals that 1 times 10 to the minus 14. So in this case, we would be solving for OH minus, which is 1 times 10 to the minus 14 divided by our H plus. Putting in our answers here, again, punching it in with scientific notation, gives us an OH minus concentration of 3.6 times 10 to the minus 10. And again, to figure out if it's acidic, basic, or neutral, we're going to compare our H plus concentration to our OH minus concentration. And in this particular case, our OH minus, which is the base part, is times 10 to the minus 10. Well, this is really our H plus right here. And that's to the minus 5. So in this case, the H plus concentration is greater than the OH minus concentration. And that means that this solution should be acidic. Any questions on that there? Okay. Perfect. We're going to skip this example. I'll scroll across the screen so you can take a look at it if you like. There you go. So the next thing we're going to talk about is actually the pH scale. And the pH scale is really a way to measure acidity. And you can forget about everything that's written on the top there. Not too important really for our class. But essentially the pH scale runs from basically 0 to 7 to 14. And the pH scale below 7 to 0, it's acidic. Above 7 to 14, it's basic. And really dead on 7, it is neutral. And it's really neutral dead on 7 because in that case, both the H plus concentration and the OH minus concentration will equal 1 times 10 to the minus 7. We'll see why that's important in just a second. As you go from 7 heading towards 0, it becomes more acidic. As you go from 7 heading towards 14, it becomes more basic. So to calculate the pH is right here, and that negative is just from PowerPoint. It's not actually a part of the formula. So the pH equals minus the log of the H plus concentration. And again, this is the same as the pH is equal to minus the log of the H3O plus concentration. Again, both of these guys identical to each other. So let's talk a little bit about pH and sort of how to calculate it and calculators, which is a good idea to know. So there's really two types of calculators. There's a display calculator and a non-display calculator. And when you have I keep having a display calculator here. If you were going to enter this formula into it, you do it exactly how it's written. You hit the negative button, not the subtract button. Again, it looks like that. You hit the log button, which you might be using for scientific notation, hopefully not anymore. And then you put the H plus concentration with your exponent number. So your number, your exponent number, and probably another negative here, and the number. So if you have a display calculator, you pretty much punch it in exactly the way you see it in the formula. If you have a non-display calculator, you need to basically go the opposite way. You need to start with the H plus concentration using your scientific notation. You then need to hit the log button, and then you need to hit the negative button. Yeah. So if you have a non-display calculator, you actually need to go the opposite way with this formula when you punch it in, and all the other formulas as well. So display, you go just like they're written. Non-display, you go the other way. Again, to determine whether or not you have a display calculator or a non-display calculator, you pretty much could just hit log. If your calculator says log, congratulations, you have a display calculator. If your calculator says error when you hit that, then you obviously have a non-display calculator as well. So that's the way that you can do that. Any questions on that there? So let's talk about everybody's favorite, which is significant figures. The number of significant figures in the concentration value is equal to the number of decimal places that you should have in the pH value that you get. So this is a place where we're not doing decimal to decimal or significant figure to significant figure, but in the concentration value. So in like the H plus concentration or OH minus concentration value, the number of sig figs you have there is how many decimal places you should have in your pH value. So to give that a try, why don't you take your calculator, and if you have an H plus concentration of 1 times 10 to the minus 5, calculate the pH and record it to the right number of digits. And we'll talk about it in just a sec. Make sure everybody's calculator works correctly. Okay, so again, if we're going to calculate the pH here, we want to use the pH formula, which is our pH is equal to minus the log of the H plus concentration. So we would just put it in and go minus the log of 1.0 times 10 to the minus 5. Now, again, following the way I told you to put it in, you should hopefully get this number here, 5 at least, that came up. So the question is, hopefully, what should we record in terms of our answer for pH? So we could record 5. Should we record perhaps 5.0, 5.00, 5.000? That's a lot of zeros, maybe not. So what the rule is for sort of significant figures when you calculate something like pH is you want to look at the concentration value, which is here. And this concentration value has two significant figures. And remember, when you write a number in scientific notation, all the numbers that come before the times 10 part are always significant. What that means is the answer that we should write for our pH is 5.00. So not two significant figures, but two significant figures gets us two decimal places when we calculate something like pH. Any questions on that? So that oftentimes also kind of confuses some people. So significant figures gives you how many decimal places you should have in the pH or any calculation like that. And we're going to talk about it shortly, but going the other way, going from pH back to H plus, the same rules apply. So however many decimal places you have is how many significant figures the concentration should have. Any questions on that there? By the way, this solution would be acidic. It is less than 7. So this solution here with a pH of 5 should be an acidic solution. Again, same thing here. You can only have it be an acidic, basic, or neutral. Same solution can't be all three. Any questions on any of that there? Okay. So I think you have a couple of examples. So why don't you take a minute or two here and calculate either the pH. Let's see here. Yeah, calculate the pH for each of these solutions here and see what you come up with. So take a minute or two and then we will talk about it. While you're at it as well, why don't you figure out whether or not it is acidic, basic, or neutral as well. So take a minute or two and then we'll go over them. Okay, so let's take a look here. So we want to calculate the pH of each of these. So looking at the first one, actually both of them, we want to use the pH is equal to minus the log of the H plus concentration. So number one, we have the H plus concentration given to us. That will give us a pH is equal to minus the log of 2.1 times 10 to the minus 5. And if we punch that in, minus the log of 2.1 to the minus 5, again, make sure you use your exponent button, and we will get 4.68 as our pH value. Any questions on that calculation? Significant figure wise, we have two significant figures here. That again gives us not two significant figures, but two decimal places when we go into the pH in this case. We also should know that when we look at it, 4.68 is less than 7, and that would give us a solution that is acidic. Any questions on that? Now, for number 2, if you got a pH of 7.23, let us see why that might not be the correct answer. So let's take a look here. So for number 2, again, we want to calculate the pH, which is minus the log of the H plus concentration. But when we look at the problem, we are not given the H plus concentration. So you cannot go directly in there with that number because that's not the H plus, but it's actually the OH minus. So here, before we could use it, we do have to use KW, which was what we were using in the previous problems, that H plus times that OH minus equals our 1 times 10 to the minus 14. That's going to give us an H plus concentration that is equal to 1 times 10 to the minus 14 divided by the OH minus 5.9 times 10 to the minus 8. And that gets us something like 1.7 times 10 to the minus 7. And now that is the H plus concentration. And now we could go into that equation. So if you went into that equation with the OH minus concentration, you did not calculate the pH. I will tell you in a second what you calculated, but you did not calculate the pH. Minus the log of our 1.7 times 10 to the minus 7. And that is going to get us something like 6.77 in this case. And this guy would be slightly acidic. Again, it is still below 7, so it's just barely acidic, but is still considered acidic. Again, neutral for our class, we will consider it 7 on the nose. So it's got to be 7.0. Otherwise, if it's above, it's slightly basic. If it's below, then it would be slightly acidic if it's really near 7. Questions on that calculation? So if you happen to have had the other number I set up there, the 7 point, we got there 2.3 perhaps. Yeah, the 7.23 is what you thought was the pH. What you actually calculated was not the pH. You calculated what is known as the POH. And the POH is equal to minus the log of the OH minus, as we will see. And that's what you would get if you actually calculated the POH there with the OH minus. And that's okay. That's 2 slides down the road here. We'll get to it in just a second. But There is a nice relationship, as we will see, that if you take the pH plus the POH, it actually equals 14, which means if you did that calculation earlier, you could have took 14 minus your POH value that you got, and what you would get is 6.77, which, as you can see, is the same pH as we got on the bottom. So as we'll see in just a second, a slide or two down the road, there's actually a few different ways you could get to the pH. POH is another way that you can maybe calculate certain of these things. We'll talk about more about that in just a second. Any questions on either of that there? Okay. So let me scroll through this. And this is what we just worked out. So again, if you're bored, need something to put you to sleep, again, you could go back and look at these and see what the answers were if you don't like my scribble. So when we do talk about pH and sort of how it changes, a couple of relationships that's important to sort of keep in mind. Basically, the pH will change by 1 for every power 10 that changes. So, for example, if you have, like we have here, basically this is 1 times 10 to the minus 3, you'll have a pH of 3. You have 1 times 10 to the minus 4, a pH of 4. 1 times 10 to the minus 5, a pH of 5. So basically, if you have anything that's 1 times 10 to the minus whatever, if it's the H plus concentration, then the pH will be basically equal to that number, as you can see there. But if it's not 1 times 10 to the minus whatever, if it's 2 point something or 1.3, you should put it in a calculator. So if you remember the relationship, as the H plus concentration increases, the OH minus concentration goes the opposite way. So they're opposites of each other. So as one goes up, the other goes down. And vice versa, as the H plus goes up. I just did that one. Let's try that again. As the H plus goes down, the OH minus concentration will go up. So they go opposites of each other. And how that affects pH is as the H plus goes up, the pH goes down. And as the H plus goes down, the pH goes up. So that is the relationship there. What really affects pH in solution is the presence of those two things. So if you have a lot of free floating H plus, not attached to anything, not combined to anything, a lot of H plus in that solution versus OH minus, this solution will be acidic. And vice versa, if you have a lot more OH minus that is freely floating around in that solution, versus how much H plus you got in there, that guy will be a basic solution. So that's truly what affects the pH, is the amount of either free H plus or the amount of free OH minus that's in the solution. And since they're essentially tied together, as one goes up, the other goes down, and it has an effect on the pH. So remember, the lower the pH, the more acidic it is, and the more acidic it is means you have more free H plus floating around. The higher the pH, the more basic it is, and then you would have more OH minus floating around in there. Any questions on that? Now, there's a couple different ways you can measure pH. Here are 2 common ways. The one over here is what is known as a pH meter. And the pH meter is basically an electrode where the arrow is kind of pointing to, that you put into the solution, and a little chemical reaction basically occurs, and it basically gives the voltage to the machine. And the nice thing about a pH meter is essentially you can stick it in the solution, and as you can see on the display there, it will digitally tell you, hey, the pH of the solution is 2.360, which in this case would mean it's acidic. It's less than 7. Another common way that you can test for pH is to use something like what's on the right-hand side picture there. That is the pH paper. And much like it shows in that picture, you essentially dip either the solution onto the paper or the paper into the solution, and it will change color. And pretty much there's a nice little kind of key, if you will, that you can match up and go, oh, well, I think it kind of looks like it matches this set of, let me try that again, this set of colors. So I think the pH is 0, or I think it matches the one next to it, the pH is 1. Obviously, the pH meter is much more accurate than, say, pH paper, but that's another way. Another way that you could test, not really pH, but you could test whether or not a solution is acidic or basic, again, is you can use what is known as litmus paper. And again, it doesn't tell you the pH, but if the litmus paper essentially turns to red, that usually indicates that it's an acidic solution. If your litmus paper turns to blue, try to spell blue there. I'm writing with blue. I guess that's good. It will turn to blue. It will tell you that the solution is basic. Again, litmus paper doesn't tell you pH or anything like that, but it will able to tell you if it's acidic or basic. If you want kind of more pH values, you would want to use something like this on the screen here. Here again is the pH scale, and we can see a lot of different things. So up there towards the top by 14, we see sodium hydroxide. Sodium hydroxide is a strong base, and we would expect it to be pretty basic. On the other end of the extreme, on the bottom near 0, we have 1 molar hydrochloric acid, which is what the HCl is, and that is a strong acid. And we would expect it to obviously be acidic. Things like vinegar, which is acetic acid, lemon juice, stomach acid, those are all obviously acidic type of solutions. Something like pure water, for example, is a pH of 7. If you don't have pure water, you may be surprised, but if you had just, plain water, or that came out of the tap, or some water that you've had out in the open for a while, it actually is usually pretty acidic. You'll have a pH of like 4 or 5, depending on sort of what you measure it. And that's because as it's sitting out in the air, it picks up some CO2. These guys come together to make what is known as carbonic acid. And essentially what happens is it increases a little bit the free H plus concentration in that solution. And as a result of that being made, the pH will go down a little bit. So, you'll find it somewhere in that area if you just take some tap water or something like that. But if you have pure water, or if you take water and you boil it, for example, as you would boil the water, what will essentially happen is you'll get rid of the CO2. You'll be left with just pure water. The pH will come back up towards 7. Any questions on that there? Yeah. So we sort of hit this a little bit earlier, but there's a very good relationship of another scale, which is sometimes very helpful when you're trying to calculate these things. And that was our POH scale. So just so we're clear, the POH is equal to minus the log of the OH minus. You calculate it the exact same way as you would punch into your calculator for pH. You just would use the OH minus. And the nice thing about that is, again, this relationship on the bottom, that the pH plus the POH will equal 14. So like the previous problem, if we were given just the OH minus, it would be good perhaps to calculate the POH first, and then you could subtract 14 from it to get to the pH. So it provides you some extra ways, or sometimes quicker ways, to get to the answers that you need. And this is also where people mess up a little bit. So pH and POH, they are opposite in terms of their scale. So if you remember, the pH scale goes from 0 to 7 to 14. Again, this is basic. This is acidic. And again, this is neutral. And the pH scale is this one, and that's the one most people remember. And that is the one you should use to determine, is it acidic, basic, or neutral? The pOH actually runs opposite. So if you have a low pH, you will have a high pOH, and vice versa. If you have a high pH value, the pOH will be a low pOH. So they run opposites of each other. And I would highly recommend, since this is usually the scale most people have in their head, that you should use the pH always to determine if it's acidic, basic, or neutral. Again, this is very common where people, again, will mess up. So for example, let's just say that we have a pH value of, I don't know, we'll do some pH of 9, for example. And if we have a pH value of 9, we could use the pOH would equal 14 minus 9. Because again, if you could keep your video off. Yes. Okay. So here we would have 14 minus 9. That's a lot of math there. I'm going to go with a 5 and hope for the best. Let's see how I did. All right. So we would want to look at the pH value here, which would tell us that the pH is 9, and that's above 7, which means this solution is basic. And what sometimes people will do is they'll go, well, this guy is above 7, so it's basic. But wait, this one is below 7, so this is acidic. And they'll give both answers because of those numbers. So again, don't do that unless you want a lot of X's happening there over it. Yeah. Again, it should only be one of those things, acidic, basic, or neutral. And always look at the pH value there when determining it. Any questions on that? Okay, so let's talk about a couple of other things while we're here. So just to kind of review all the math stuff that we got going on here, the Kw is our H plus times our OH minus, and that equals 1 times 10 to the minus 14. Again, that will allow you to calculate the H plus or OH minus concentration. You could take the pH is equal to minus the log of the H plus concentration to calculate the pH. You could also calculate the pOH, which is minus the log of the OH minus concentration. And again, the pH plus the pOH equals 14. That's a nice relationship. Now, if you have the pH value given to you, if you think about it, from the pH value, you could actually calculate the H plus concentration. So if you're given the pH value, to calculate the H plus concentration, this is the inverse log of the minus pH. Now, when you type the inverse log on your calculator, this should put a 10 and a caret up there in most people's calculators. Inverse log, you could get to usually top left of your calculator. There's like a second button. There's like a shift button. And there's a log button somewhere is usually where you find the 10 to the X. And that's probably what a lot of people has been using for scientific notation, but this is actually where you should use it. And you want to make sure it is negative when you do that. There's a similar one as well. If you're given the pOH, from the pOH value, you can get the OH minus concentration. And the OH minus concentration is the same calculation. It's the inverse log of the minus pOH. And again, that is your 10 and a caret usually when you hit it, minus pOH. So using all of these sort of formulas that we have seen, we'll do some example of those last ones in just a second. gives you actually a variety of different ways that you can solve these problems. And there's really no right or wrong way to do it, depending on sort of which path you choose. If you choose a correct path, they all should pretty much get you to the same spot when you're done, no matter which way you did it. So there's multiple ways you can kind of solve some of these problems. And again, as long as you sort of do the calculation correctly and pick sort of the right path, you should get to the same spot. Any questions on that? So pretty much what's on top of the screen there, you should know, you'll use a lot. You need to know how to sort of do these calculations. So let's get into some of these here to see. So why don't you give these guys a try here, I think. So for each of these, why don't we do calculate the pOH and the pH. And also while you're at it, why don't you figure out whether or not it is acidic, basic, or neutral. So I'll give you a couple of minutes there for each of those solutions, calculate the pH and the pOH. And while you're at it, calculate for this guy, calculate the OH minus concentration. And why don't you calculate the H plus concentration for this one as well. So I'll give you a few minutes to work on those, and then we'll talk about how to calculate all that stuff in just a second. Okay, so let's take a look at these. So we pretty much want to calculate everything other than what was given to us, and also try to obviously figure out whether or not it's acidic, basic, or neutral. And let's take a look at the first one here. So our first one, we're given the H plus concentration, which is 3.6 times 10 to the minus 9. And because we're given the H plus concentration right off the bat, we can calculate the pH, which is minus the log of the H plus. So that might make sense to do that. So we'll do minus the log of 3.6 times 10 to the minus 9. And if we put that into our calculator, got one here somewhere, 3.6 to the minus 9. That's going to give us a pH value of 8.44. Again, here, the concentration has two significant figures. We're going to go to 2 decimal places in this case. Now, once we have the pH, any questions on that? Once we do have the pH, probably the pOH can be found pretty easily by using that relationship that the pH plus the pOH equals 14, which means that the pOH would equal 14 minus the pH. So that's going to give us 14 minus 8.44. And that will get us a pOH of 556, so 5.56 as our pOH. Also 2 decimal places because of the significant figures in the answer. Any questions on that one? Now, we also are looking for the OH minus here. And really, you do have 2 ways to get to the OH minus. You could use KW like we did in the previous problems. And again, that would look something like 1 times 10 to the minus 14 divided by 3.6 times 10 to the minus 9. And then you could use what we just learned, which was that if you take the pOH, you could get the OH minus from it by taking the inverse log of the minus pOH. So again, if we were to do this method here, we would hit the inverse log, which again is the shift or second button, usually top left of your calculator, and the log button. And I usually will put a 10 and a caret up, minus, so make sure you make it negative 5.56. So usually on your calculator, it'll look something like this. And if you do it that way, you will end up with a OH minus concentration of 2.8 times 10 to the minus 6 molar. And by the way, that is exactly what you'd get if you did it the other way. You should get the exact same way. And again, like I said before, there's multiple ways you could sort of solve these problems. It just sort of depends on which way that you go out at first. And that would give us our OH minus concentration. Any question on that? Alternatively as well, you could have got the OH minus and then just went into the pOH equation using KW, and you could get there as well. So there's many different sort of ways that you can get to these answers. Again, as long as you choose sort of the right way or a right way, should get you to the same answer regardless of which way you go. Lastly, here we want to determine, is this acidic, basic, or neutral? Again, Although we have a lot of numbers to look at, always the pH is what we want to look at. So always the pH value here. And we see that the pH value is above 7, which means that this solution should be basic. Any questions on any of those numbers there? Okay, so let's take a look then at the second one, which is the OH minus. Switch up the color a little bit here. So in this case, since we do have the OH minus given to us, we can directly, if we wanted to, get the POH. We also could get the H plus using KW. The POH would equal minus the log of the OH minus. So that's going to be minus the log of 9.2 times 10 to the minus 2. That is going to give us a POH value of 1.04 for our POH. We then can figure out the pH by taking 14 minus it. So 14 minus our POH will give us a pH value of 12.96. And again, you have a choice as to how to get the H plus concentration. So if we do it the same way as what we're talking about, that would be the inverse log of the minus pH, which again on your calculator, if you put that in, will look something like this. And if we do that, we will end up with 1.1, it looks like, times 10 to the minus 13 molar for our H plus concentration. Any questions on where any of those numbers came from? Now, when we went backwards, as you can see from here to here, going from pH or POH, the number of decimal places in this case was 2, which means we ended up with 2 significant figures as we went backwards. So again, you want to keep track of that as you go either from concentration to pH or POH, or backwards from pH or POH to concentrations. Lastly, we do want to figure out, is it acidic, basic, or neutral? Again, we want to look only at the pH value, which is this guy. That is definitely above 7, which means this is also basic. Any questions on how I got any of those numbers, where they came from? Did I make it up? I might have, could be, you never know. My first day, you never know. Any questions on any of that stuff there? If you do, feel free to type it in. I'll get to your question if you do have one. I will scroll through this so you can see it, in case you want to look at it later again to help you sleep. This again is everything we just did, or most of what we just did on the previous page there. And there we go. All right, so I think you have another example here. So why don't you give this one a go? The pH of the solution is 5.67. What is the POH? And while you're at it, why don't you calculate, just to make sure, why don't you calculate the H plus concentration and the OH minus concentration? Give that a go. Take a minute or two, and then we'll talk about it. Okay, so let's take a look here. So in this problem, we're given the pH, I believe. Yep, given the pH, and we're looking for the pOH and a bunch of other things. So again, the first thing would be easy to do is use that relationship that the pH plus our pOH equals 14, which in this case, if we want the pOH, that's going to be 14 minus our pH, and that would give us 14 minus our 5.67. So we're just going to subtract here. So that's going to be 14 minus 5.67 gets us 8.33 as our pOH. And again, you do have a variety of ways you could kind of get there, but I'm going to start here since I have the pOH. And since I have the pOH, I can figure out the OH minus concentration from it. And that's the inverse log of the minus pOH. So punching that into our calculator gives us a 10 and a caret. Make it minus 8.33. And if we do that, that will give us an OH minus concentration of, looks like 4.8 to the minus 9. And again, since it's a concentration, you do need to put the molarity on it at the end. Same thing here, 2 decimal places gets us 2 significant figures when we get that way. And at this point, again, you have 2 ways to get to the H plus. You could do the same thing with the pH. So the H plus will equal the inverse log of the minus pH, which again will look like 10 and a caret minus 5.67. And if you do that, you will get, sorry, dramatic pause there for a second. You'll get a 2.1, looks like to the minus 6. Again, you would put the molarity there since it is a concentration. And the opposite way you could have got it was the H plus would equal 1 times 10 to the minus 14 divided by our OH minus, which we calculated over here, 4.8 times 10 to the minus 9. And that will get you there as well. So again, there's a couple different ways, depending on sort of which path you choose as to which way you do it. And while we're here, the solution should be acidic. Yeah. The pH here is what we want to look at. It's 5.67. That is less than 7. So it will be acidic in this case. Any questions on how I got any of these numbers, any of these calculations? Obviously, you need to be able to do all these calculations here. Any questions on any of that? Okay, so it's probably a good stopping place. We're pretty much almost done here with with this chapter. There's a few more examples like this, and we're going to talk about buffers on Wednesday as well. And then we will roll into organic, which I think is chapter 10. So a reminder, I believe we're skipping chapter 9, which is nuclear chemistry. We weren't doing it anyways from the beginning. So we're going to go from chapter 8 to chapter 10, which will be our first chapter of organic chemistry. And then, like I said before, at that point, no real calculations or anything. And all the organic ones, more memorization and stuff like that. So we'll wrap up the rest of this chapter on Wednesday in lecture. We'll roll into chapter 10, which is organic chemistry. And then a reminder that the exam was moved to 1 week from today. And again, it will happen on Monday. It will cover chapters 5, 6, and 7. And we'll cover chapters 5, 6, and 7. And we'll be done through Canvas. And I'll give you obviously more information before Mondays. It might be over the weekend, but at some point before Monday, you get some more information on that. So you'll log in on Monday and take the exam. And it'll probably be scheduled during our normal lecture time, and you could take it during that time. So we probably won't have a lecture on Monday. That'll open up that time period there for you to take the exam. I'll still be around, obviously, if you had any questions or anything while you're doing it, but everything will be done through Canvas. You'll need to probably have some paper to work out some of the problems that involve work. There'll be kind of two parts, just like a normal exam, I think it will be. There'll be kind of multiple choice questions, and then there'll be kind of workout type questions like normal. So you'll have to upload your work when you're done with the exam, just like normal, showing obviously all the work, the setup, the units, and everything like that. And again, the purpose for that, as I might have mentioned, is if I just leave it all multiple choice, it's a all or nothing type of situation, and you can't get any partial credit. So with you uploading your work, at least if you miss the answer, I could go and at least try to get you some partial credit and stuff like that. And again, we'll have more information on Wednesday about that. And any questions on any of that? Okay, so we're going to take a little break here, and maybe about 10-15 minutes I will start the discussion section. So if you have questions on that, you can feel free to join in and ask your questions. I'll hang around for kind of our normal time, and you can do that. Other than that, if not, I will see you on Wednesday where we'll finish this up and go into our sort of lecture there and finish up chapter 8 and then off to our organic chemistry. All right, so if you're out, have a good one. I'll see you Wednesday. If you're going to hang out and come back for discussion, make sure you sign back up for the discussion. And I'll see everybody in a bit.